So on this front page, all we're doing is plotting and labeling the points. Please make sure you label them A, B, C, D, or whatever it is, because I have to know which one's which, okay? And I put 2 different grids on here because once you put like several points, it starts to get kind of cluttered. But all you do is rotate that amount, whatever the pi over whatever is, and then go that distance away from the center, which is called the pole. All right, so 5 pi over 6, what quadrant is that in? Second quadrant, it's going to be this line right here. And I don't have a better explanation than here looks. So you're going to kind of have to look at it, right? Here's our 5 pi over 6, and we're going to go 4 units away from the pole. So right here is A. That's all that there is to this. We're just going to plot and label these points. All right, so 5 pi over 4, that would be in the third quadrant. That's this line right here. And but we're going to go -7. So it's backwards. So which quadrant are we actually going to end up in? Yeah, first quadrant. You're going to go like out the other side and go 7 along this way. And the 5 and the 10 are kind of bolded, so that can kind of help you count a little bit. So like if I know this is 5, go 2 more, that's 7. All right, negative pi over 6 will be this line right here. You're rotating backwards, and we're going to go 8 units away from the center. So C will be right here. Negative pi over 3, again, you're rotating backwards. So negative pi over 3 will be this line. But again, we're going backwards. So you go like out the other side, like to the other direction. So that's going to put us in quadrant 2. It'll be right here. And then 4 pi over 3 is in the third quadrant. That's going to be this line right here. And we're going 9 away from the pole. So here is E. And again, once you have like up to 5 points plotted on there, it's just kind of cluttered. So I gave us a different grid for the other ones. So here, pi over 3, first quadrant, but we're going -7. So that's going to put you like out the other side. It's going to be down here is F. Pi over 4, and then 5 units away. So here's your line for pi over 4. 5 units away will be right here. That's the one that's kind of bolded. So that's G. All right, -2 pi over 3. So you're rotating backwards. That's going to put us along this same line that point F is on, but we're going backwards. So that takes you out the other side. And so 3 units away will be right here. So this one is H. All right, 7 pi over 4 will be in the fourth quadrant. That's this line right here. And but we're going -6. So that takes you out the other side. It's going to be in the second quadrant. And so I is right here. All right, and then negative pi over 6 going backwards. So fourth quadrant is going to be this line right here, and then 10 away from the center. So this is J. How do we feel about plotting points? Like, are we okay? Cool. It's just plot the point on there. That should be like 10 easy points. All right, these are the ones that are on the axes. So we're going to write these in both rectangular, that's what you've been used to forever, and then polar form, which is the new stuff that I'm teaching you. Let's go and do them all in rectangular first. What are the coordinates for point A? Yeah, 0, 8. And then how about B? 6, 0, cool. This is like welcome back to Algebra 1. And then C would be 0, -2. Now, when you go to write them in polar, it's R, theta, which does annoy me because you have to rotate first and then go that amount. But decide how far you've rotated and then how far away from the pole you went. So for A, how far did we rotate to get there? It's pi over 2 and then 8 units away. So 8, pi over 2. How far did we rotate for B? Like nothing pi, right? And we're 6 units away. So 6, 0 pi. And then for C, we're 2 units away. So 2, and then how far did we rotate to get down there to C? 3 pi over 2. Perfect. Those aren't bad either. All right, these are your conversions. I still have them written on the board, but those will be gone next week, okay? Now, always draw a picture first, because if it lands on the axes, then you don't have to do any work. You can kind of just write the answer, and you know I'm going to throw you a couple of those, all right? So for example, 2 comma pi over 2 would be right here. You rotate up to pi over 2 and then go 2 units away. So we don't have to do any work for that. What's that coordinate point? Yeah, 0, 2. So like, you know, don't do any work if you don't have to. Just draw a little picture. These ones we're going to have to actually work out. Still draw a picture so that you know what quadrant you're in. 3 pi over 4 is in the second quadrant. Bless you. So it'll be, you know, like that, like we rotate to here. Whenever I dot these in, I'm just trying to draw like these lines that are on here. I'm just not drawing all of them. And then 7 units away. So like somewhere out there. The point is you're in the second quadrant. It's just good to know that. Okay, so converting to rectangular, we're going to use these ones over here. We need to find x and we need to find y. X equals r, so it's 7 times cosine of theta, which is 3 pi over 4. And y is r sine theta. Now, I had in the past required you to draw a picture for these. We're kind of beyond that. So if you don't, that's fine. If you need a picture, certainly do that though. I'm saying it's optional is all I'm saying. Here's your picture for 3 pi over 4. But if you can envision that in your head, that's fine. I'm not taking off points if you don't draw it. But you of course can. All right, so which one of these is the cosine part? Yeah, the negative one along the x-axis. So this is going to be 7 times negative square root of 2 over 2. And then sine is this one. So 7 times positive square root of 2 over 2. And then you just have to write your answer as x comma y, like it should be an ordered pair. So it is negative 7 square root of 2 over 2, comma 7 square root of 2 over 2. And if you drew a little picture, you can use that to be like, oh, are my negatives correct? Well, yeah, in the second quadrant, you went negative and then positive, like left and then up. So you can use that to check. All right, again, I'm just going to draw a quick picture of this. Pi over 6 is in the first quadrant, but we're going -3, so backwards. That's going to put you in the third quadrant. And again, it's just good to know what quadrant you're in. It only takes a second. And then we're going to do the exact same thing we did here. So x equals -3 cosine pi over 6. Y equals -3 sine pi over 6. And then you have to evaluate those. So again, at this point, if you can imagine the triangle, I'm not going to take off points if you don't draw it, but certainly you're like allowed to, right? Here's pi over 6. And actually, I'll ask you guys, hey guys, what goes across from that? Yep, 1/2, good. And then this is square root of 3 over 2. So cosine is the x part of that. That's the square root of 3 over 2. And then sine is the 1/2. And so again, just make sure you write it as an ordered pair. It should be x comma y. So it's going to be -3 square root of 3 over 2 and -3/2. And again, that makes sense to be in the third quadrant. Both of them are negative. So you can just use that to like help check your work. All right, converting to polar. Same thing, I would draw a picture first, and actually I'm going to start with B because I noticed that one has a 0 in it, and I know that's going to be like a no work one. -9, 0, you would go over here, you know, 9 units. I'm not going to draw 9 little tick marks, but -9, 0 would be right there. That's on the axis, so you don't have to do any work for that. What would that be in polar? Like we went 9 units away, and then how far did we rotate to get there? Pi, good. So 9 comma pi, and you don't have to do any work. Right, -1, 1 would be in the second quadrant. And again, it's good to know what quadrant you're in, because especially we have to figure out how far we rotated. And you're going to use these ones. It's Pythagorean theorem to get r, and then tangents to get the angle. You need r comma theta. So we're going to do x squared plus y squared equals r squared. And when you square a negative, it's going to turn positive. So what is this going to give us? 2. 1 plus 1 is 2. And so r is square root of 2. Technically, it's plus or minus, but pick the positive one. Like if you have a choice, pick the easier way to do it. All right, and so that's r. Then we need theta. Tangent of theta equals y over x. That will be 1 over -1, which would just be what? Yeah, it'll just be -1. Now, we're in the second quadrant, so we need to figure out how far did we rotate to get into the second quadrant, and tangent ends up being -1. Good, it has to be the fourths because that's where you have the square root of 2 over 2. It ends up being -1, so we went 3 pi over 4 is our angle. And then just make sure you write it as r comma theta. It's square root of 2 comma 3 pi over 4. And then we're going to do the exact same thing with this one. So it's Pythagorean theorem to get r. Ooh, this is going to be interesting. Let's see what we get here. 1 squared is 1. Square root of 3 squared. We're just going to do the numerator and denominator separately. Square root of 3 squared. What would that give us? It'll just be 3. And then 3 squared is 9. So actually, we can reduce that. What would 3/9 be? It'd be 1/3. So 1 plus a third. Okay, I realize that'd be 1 and a third, but I don't want to write it as a mixed fraction. That would be 4/3. And then we're going to square root both sides. So square root of 4 is 2, square root of 3, square root of 3. And then if you rationalize that, it's going to be, oops, I ran out of room. 2 square root of 3 over 3. That turned out weird. All right, anyway, that's r. That's what r came out to. Oh, and I forgot to draw a picture for this one. What quadrant is this going to be in? Yeah, because they're both positive. Like, I don't know exactly what this would be in decimal form, but, you know, somewhere over here. The point is, it's in the first quadrant. So now we need to figure out what the angle is. How far did we rotate to get there? Tangent of theta equals y over x. So that would just be square root of 3 over 3. Now we need to take that backwards though to figure out like what that's going to be on the unit circle. So if we go backwards a step, we're going to like unrationalize that. So what would that give us? Yeah, oh, you jumped straight to the answer. I'm going to write the middle step, but you're correct. It'll be 1 over square root of 3 if you like go backwards a step, and that would be 1/2 over square root of 3 over 2. Now, if you don't want to draw the triangle, again, I'm not taking off points for that. I don't care. If you can envision it in your mind, that's fine. But here's what that triangle would look like with the 1/2 and the square root of 3 over 2. So what's our angle? What's our amount of rotation? That's what we're trying to get here. Yeah, pi over 6, good. But if you could envision that, or if to be really honest, if you were like, I actually don't care anymore, I'm going to just take a stab at it. I know it's pi over 4, pi over 3, or pi over 6, you know, take your guess, right? And then just make sure you write it as r comma theta. So that's what we did on the first day. We did plotting the points, and then we did those conversions. The conversions are probably the hardest thing on there, in my opinion. All right, and then the second day we did the graphs. So do you remember what it looked like when it was just r equals? Like what shape did we get? So circle, all right? Here, the radius is 1. So you're going to go 1 unit in each direction, draw a circle, like a little baby circle. He's so cute. And then you have to write it in rectangular form. So that would be what? You're using one of these. Good, x squared plus y squared equals, now r is 1, so 1 squared is just 1. This is going to be the exact same thing, except your radius is 5. So go 5 units in each direction. And just do your best to make it look circly. I'm not grading your art skills, just Do your best. And then what would that equation be? Perfect. 5 squared gives you 25. So if it's just r equals, it is a circle. That's your radius. If it's theta equals, it's going to be a line. You just have to figure out what the slope is. And we're going to use that tangent of theta equals y over x. It's going to be a line. You just have to figure out what the slope is. And you do that by evaluating this. If you want to draw the picture for 3 pi over 4, you can, or you can just kind of imagine it. This is going to be in what quadrant? Second quadrant. Both of the sides are square root of 2 over 2, except one of them's negative. So if you evaluate that, tangent of 3 pi over 4 will be -1. And then you just want to get y by itself, so multiply over the x. So y equals -1x, or just -x. But that's going to be a line with a slope of -1. So you're going to go through the origin and then down 1 over 1. So again, you're pretty much just figuring out what the slope is, and it's going to be a line. So this one, we're going to do the exact same thing. It'll be tangent of negative pi over 3 equals y over x. Tangent is going to equal y over x, opposite over adjacent. Now I will draw a picture for that one because it's rotating backwards. Negative pi over 3 will put you in the 4th quadrant. And so it'll look like that. But again, if you don't want to draw that, I'm not taking off points. Right? If you can like envision it in your head, that's fine. Tangent would be y over x. Okay, if you put this over this, what is going to happen? This one over this one. 2's cancel, you'll just get negative square root of 3 and then equals y over x. And so again, just multiply over the x, you get y equals negative square root of 3 times x. Just do your best. Negative square root of 3, it's negative 1.7 and then more decimals. So go through the origin and then just like as long as it's between 1 and 2, you're fine. Like good enough. You're going down square root of 3 and then over 1. And again, it's like between 1 and 2. All right, and then if you have a secant or a cosecant, it's going to either be a vertical or a horizontal line. We're going to use these right here. For number 9, we're going to use the y equals. It's y equals r times sine theta, and this is r. So it's, you know, that times sine theta. And then do you remember what we did with that, or like what happened with that? Yeah, like this, the cosecant turned into 1 over sine, and then the signs canceled. So these just go away because they're reciprocals. You get y equals -5. So then like the $1 million question is that vertical or horizontal? Horizontal, good. It's the Hoy of the Hoy-Vux. Horizontal is y equals. So a horizontal line at -5. And then this one's going to be the same thing, but we're going to do the x equals r times cosine theta. So this is r, and then times cosine theta. But again, secant and cosecant, excuse me, take 2. Secant and cosine are reciprocals. You can replace this with 1 over cosine, and then they're going to cancel out. You just get x equals 3. So that is a vertical line at 3. Okay, so these ones we need a calculator for, and let's just review like what mode you need to be in. So everyone go to mode, it's right next to second. You need to be in radians, and you need to be in polar. It probably already is because I've been doing this in every single class, but if it's not, you need to be in radians and you need to be in polar. And then when you go to y equals, instead of y equals, it will say r equals, and you can go ahead and type that in. Do you remember how you get the theta? What button do you use for theta? Yeah, it's the xt theta, and it just depends on what mode you're in, which one it gives you, but the variable key. And then let's talk about window real quick. You want your theta to be 0 to 2 pi, and then a step of 0.1. It probably is, again, because I told everybody to change it to that. And then for the x's and y's, I would do -5 to 5. You can change it to -10 to 10. You know, I have the grids on here, -5 to 5, so that's what I would leave it. Oh, that one's cute. I like that one. Really cute. I'm requiring you to plot any points that you can see specifically. And then beyond that, just do your best to copy it. I'm not grading your art skills, but I see 1, 2, 3, 1, 2, 3. I see 5 points that you can plot specifically. So can anyone give me one of them? What's one point we can put on here? All right, 0, 0. Perfect. What else? 0, 2. 0, 4. Yep, 1, 0, -1, 0. That's the minimum requirement, is whatever points you can see, you can just look at them and see them, plot those, and then beyond that, like, just do your best. And it's going to look different than it does on here because this gets kind of like stretched out just by the nature of how the screen is. So it's not going to be like, if you're a perfectionist, I'm terribly sorry, but you're going to have to like take some deep breaths and like move through it. It's not going to be perfect. All right, then you're going to go back to y equals, clear that out. Now we're going to type in this one, 3 + 3 cosine theta. And you don't need to mess with the window again. Just, oh, you know what? I forgot that I did this. This one, I'm so sorry. I'm sorry. I'm really sorry. Do you forgive me? This one does go off the grid a little bit. Go back to window, make your X maximum instead of 5, like make it 10. I don't think it needs to go all the way out to 10, but that'll be good enough. And then you'll be able to see it. So it's a heart, or what did you guys call it? A lily pad? It's supposed to be a heart. They're actually called cardioids, like like that's the official name for them. Like they're a type of limicon. Anyway, what are the points? I see 1, 2, 3, 4 that we can plot. I'll give you a hint. One of them 0, 0. What else? 0, 3. 0, -3. Thank you. And then how far out did that go? Is it 6? I'm sorry, it went 1 off the grid. I apologize. All right, and we're going to go back to y equals, clear it out again. We're going to type in the next one. 5 cosine 2 theta. So it's like a little 4-leaf clover. So you're going to plot 0, 0, and then it's 5 in each direction. And that's because of this 5 that's out front there. So again, just plot those specifically, and then the rest of this is like, you know, just do your best. It's like a roundabout on the highway. And then we'll clear it out for the next one. 4 sine 3 theta. that one has 3 petals. And there's only 2 points you can plot specifically there. You can do 0, 0, and then where's the only other one that's like, you can see is exactly like nicely on a point? Yeah, 0, -4. Each petal is 4 units from the center. It's just these ones aren't like, they're kind of floating out in space. So, you know, again, just plot those 2 and then do your best. It's not technically going through 1, 0. It's like, if you were to zoom in, it's like just above that. Yeah, like if you plot a point that's not technically a point, that is incorrect. But I mean, yeah, if there's an even number of petals, think of it this way, if there's an even number of petals, you're going to be able to get these. If there's an odd number, only one of them is going to line up. So you just won't have any other points. Looks like a little propeller blade. All right, and then last one, this one's gonna be a circle. Go ahead and clear it out. We're gonna type in 2 sine theta. And so you can plot 0, 0, and 0, 2. And then just connect it and make a circle.